Hi, today we're going to look at the type 3 and type 4 conversions. I've solved these questions. Let's look at the first equation. I've balanced the equation. It's pretty simple. It's just synthesis of water. The first question, what I want you to do is underline what is asked and what is given. And then you begin with what's given. In this case, we are beginning with 5 moles of hydrogen. And then you set up the mole ratio between what is given, the 2 moles of hydrogen on the bottom, and the 2 moles of water on the numerator. Since it's asking you grams of water, you need the molar mass conversion. So that's the molar mass of water that comes from the periodic table over 1 mole. You can simply check your work by canceling out the units, and you have to end with the unit that's asked in the question. So I'm canceling out the moles and moles and moles of water and moles of water. I end up with grams of water. So I know I'm in the right track. Once you set up, you multiply all across the numerator and divide by the denominator. In this case, the 2 and 2 gets canceled, so it's 5 times 18, which is 90 grams. Looking at question number 2. Here, the asked is moles and the given is in grams. So you begin with 5 grams of hydrogen. Since it's in grams, you cannot go into mole ratio immediately. You need to convert it into moles. So you divide it by the molar mass of hydrogen. Each hydrogen is 1 gram. So since you have 2 of them, it's 2 grams on the bottom and 1 mole goes on the top. And then you choose the mole ratio between what is given, which is the hydrogen that's on the bottom, and what is asked, which is the oxygen. So these numbers come from the reaction equation up here. And then you plug it in and you just solve. So it's 5 times 1, 5 divided by 2 times 2, so 4. So 5 over 4 is 1.25. The next one is a mass-to-mass conversion. This is your longest conversion. So you begin with 15 grams of water, and then you convert it into moles of water by setting up 1 mole over the molar mass of water. Then you choose the mole ratio between water, which is given, and oxygen, which is asked. Now note that oxygen is diatomic, so there are 2 oxygens, so you're multiplying 16 times 2, which is 32 grams of oxygen. Again, multiply all across the top, divide by the denominator, you get the final answer. This last one here is a combustion equation. I've balanced it here for you. And then the setup is very similar to the last one. Since you're going from mass to mass, you begin with 25 grams of C8H18. You divide by the molar mass, so it's 1 mole over the molar mass. Then you choose the mole ratio between CO2, which is the asked, and the given. That times the molar mass of what is asked, 44 grams CO2 over 1 mole goes on the bottom. Solve, use your calculator, 77 grams will be your final answer. We also gave you these 2 equations so you can actually use it to do your last 2 practice problems. We gave you the final answer for these problems. So you have it here. So you can set it up, put it in your calculator, check it, and then see if you get the same answer. If you look at the conversion, I just want to point out that whenever you use molar mass, 1 mole always goes along with the molar mass, and the mole ratio comes from the balanced chemical equation. Always show your work, because by showing your work, you know exactly where how you've set up. You know you're asked, you know you're given, so it's easy to keep track of your work. Okay, thank you very much.